Yes, by the grace of God, I will.
Yeah, so when you get done here, you go to a wonderful kitchen and you brew a cup of tea.
Okay.
And yeah.
And get some rest before I go to work.
Some rest before you go to work. That's right.
Yeah.
Maybe you take a chai tea that will relax you and get you good rest before you go to work.
Yeah.
So good.
Yeah, it does.
It does, yeah.
Thank you for the remedy. Thank you for the remedy. May need it.
Yeah.
Is it weak or strong acid base? I'm sorry, I just kind of woke up.
Well, if you just woke up, just kind of run your index finger across your eyes, then you woke up.
Right. Right. Thank you for the laughter. It will help.
Hang in there, Shante.
I'm trying. I promise y'all. I'm really trying. God knows I am. Really trying.
All right. Okay, guys. So it's nice to see you. And this is our last lab for the summer.
Yes, it
is. It has been a pleasurable experience and enjoyed having you guys. Unfortunately, we didn't get the opportunity to see any of ourselves. We just those like Shante is not herself. She's those manufactured View, and Sitali is also manufactured View, and there's some other person, but that's okay. I know I know the voice of those who've been talking, and I can recognize you when I see you and you talk.
True.
So it's been a pleasure, and I hope to see you guys either in Chemistry 101 or 102 or 211 or 212. And I'm wishing you guys the best, and I hope you succeed in all your endeavors. Now, one word of
Thank you so much.
Yeah, one thing that I gotta say, this is my 41 years of teaching college, and not just community college, but universities and pharmacy school. Mm-hmm. So when you tell me you what is that thing? Chanel usually uses that word, visual learner.
Right, she did say that.
Please don't don't imprint that in your mind that you're a visual learner.
Okay.
Because that's what the social psychologists have developed in the last 5-6 years to separate the people who are, go get it people from those who are, want to be taught. So you can do it.
Yes,
okay, you can do it. Don't underrate your ability by saying you're only a visual learner. Like I said, we are all visual learners. Otherwise, there will be no traffic signs.
Right.
Okay, so I wish you all good luck. And if you become a nurse, like Shanti is hoping to be, or already are, I hope that when I get into my nursing home, that you will be the nurses that will come to take good care of me.
Right.
And I mean when I'm old, and not for COVID-19, because that's going to go away, and we'll all march on to greater heights in the future. So thank you guys for being a part of my life, and I will see you guys in future.
Yes. Thank you, Professor,
You're
Thank you.
welcome.
for the uplifting words. Yes.
Thank you, Dr. Ibe.
You're
Yeah,
welcome.
for helping us get
Thank
through
you, Dr. Ibe.
So for the lab today is acid-base titration on unknown HCl.
Right.
And when I opened that particular lab titration lab, my HCl unknown is number 12. Yours might be different. So that place it says what is your unknown sample. You just put the one that is
Okay.
showing
Unknown
on yours.
for yes.
And if you look at it, you see that there is a beaker with the pH probe and the conductivity probe all in it, and that solution is yellowish.
Yeah.
Right.
Okay, so a word of caution: you're gonna do that when you get to let's see, when you get to say about 6 pH of 6, then you're gonna do it slowly, because if you overshoot, then if you want to do it over again, even when you add that bromcresol green, it's not going to change color. So
Okay.
just be careful. You'll be looking for a blue color.
Blue color. Okay.
Blue color. So that bromcresol green thing is just the name the person who synthesized that product called it, because of some kind of UV thing, which we are not going to go into. But you're looking for a bluish color. Okay.
Professor. Professor.
Yeah.
That was trying to get in. Trying to get in.
Who, Alicia?
Yeah.
Okay. So now it's a very, it doesn't say if you repeat it. So try to do it as careful as you can, and it's a one-shot deal, so that you're gonna be happy with yourself and with all of us. Yeah,
And we're
when
going to 12, correct? 12 pH?
pH of 12, approximately pH of 12. Now the data on the lab notebook will show. You do not, if you copy it, that's fine. But it will show you exactly where its own pH equivalent point came about. Could be out at 12.00, which will be very hard for you to get, or 12.01, but do not just let it run, okay?
Okay.
All right, so let's get started.
Okay.
So what's our unknown sample number?
The one on my bench is 12. You know, you can, that HCl, it could be different in yours. What does it say?
Mine is for the pH, right?
No, the HCl.
Oh, okay. 14.
All right, so you're gonna put 14. You and your group.
Okay, thank you.
Yeah.
Okay, Professor. So all we are doing is we are gonna fill in the liquid that's being balanced with the two. I forgot about
It's already ready. If you look at the Burette Zoom view,
yeah.
it should say that meniscus should be on the 0 calibration. So it is ready to go.
I'm sorry. So do I? So I just uh fill it, right? I don't have
To
to.
fill what?
I forget the beaker.
The
That
big your beaker is on the steering
on the scale.
on the steering plate, and it is yellowish, right?
Yes.
Okay, so it's ready to go.
Okay.
So all you're gonna do is it says perform the titration, click that save button in the Burette Zoom, and then you follow that instruction step by step. Do not overshoot to 12 point anything, because if you want to do it over again, you will never, if you add the bromcresol green, you will never get a yellow thing.
Okay. So all we're doing is we're going to raise the pH to 12, right?
Yeah, keep adding this the sodium hydroxide until it gets to a pH of 12.
Okay, perfect.
Professor, I'm sorry to get in right now, but Anna Marie Bernal is waiting and she wants to be let in.
Thank you.
Yeah, you're welcome.
And Professor, what's the equivalent point? Is that the pH?
Yeah, the equivalent point is where that yellow color will suddenly change to bluish color.
Oh, okay. So that's on the graph, right?
Yeah,
Okay.
and that's where the acid has neutralized the base.
Okay.
Oh, wow.
Professor, you said don't go over 12, correct?
Try not to go over 12, but if you went over 12, when you go to the lab book, you can see where the actual 12.00 corresponds to the volume.
Okay.
See, when you get, if you are doing that, if you are gushing it, by the time it gets to 3, you should slow it down, because after that,
Okay.
by the blink of the eye, we'll get to 12.
Yeah. It went to 12 point, wait, let's see, pH. Hold on, let me see. Went to 12.1, but it stopped at 12.0.
All right, so yeah, then if you got 12.0, that's fine. And your 12.0 will probably be giving you something like 18 point something mils.
They gave me 16.81 volume and 12.40 conductivity.
Okay, that's good, and that's fine.
Okay. So then we just go ahead and plot it right on the spreadsheet.
Yeah, then go ahead and plot it and use, it says on number 6, it says calculate the molarity of HCl using the 25 mil HCl solution and volume of the 0.2564 molar sodium hydroxide. So it's giving you the data to use. And it is like the calculation you did yesterday? Yes. Okay.
So it would be the 25 ml divided by the 0.2564.
The other way around.
Oh, 0.2564 divided by the 25.
25 in liters.
Also, the unknown, what is it? Let me read it again. What is it? The unknown sample number. Are we doing the math with the sodium hydroxide or
the unknown sample number is what is written on the bottle of HCl that you have.
Okay. Unknown HCl. Okay, perfect.
So when I calculate those two and divide those two, then I take that number, I believe, I can't remember, but I take that number and divide it by the pH, right?
No, you divide it by the volume.
Oh, yes. Okay.
There's a couple of other relationships that are involved in that calculation, but it's something that we'll do if we were seeing each other in class. You can see the relationship between the equivalence of one and the equivalence of the other. But right now, just do what the guy tells you to do.
Okay. As far as number 5 of the volume, that was, the volume of the 0.2564 m in NaOH was required by the saturation to reach the equivalent point.
That's right.
So that would be what the data have given
to you, yes. But it's telling you, okay, now just calculate the molarity of the HCl using the 25 mils of HCl that was titrated and the volume of the 0.2564 molar sodium hydroxide from your titration.
I think I'm confused.
I am too.
Yeah, I think I'm confused.
But you said
from yesterday.
Let me see that one. I gotta bring it out so I can look at it.
Wait, Professor, can I ask? You said the 0.2564 divided by 25 milliliters, but in liters?
No, this would be to find, you're gonna, okay, the relationship in this thing is that at the equivalent point, the molar concentration of the acid is equal to the molar concentration of the base. So if you were to find the volume of the base that was used, it's telling you now that it is really equivalent to the molarity of the acid at 25 mils of the HCl. So using that equation that says molarity equals moles divided by volume in liters, you're gonna find the molarity of the HCl by the relationship that at the equivalent point, the molar concentration of the acid is equal to the molar concentration of the base.
But you're talking about number 5 or number 6?
Number 6.
Okay. So, and hold on, let me calculation. It gives a 0.000, like 3 zeros, and then it gives the number, like how we did yesterday.
And that is?
For number 6.
Okay. What is the volume of the HCl?
Well, mine is 16.81.
Okay. So what you're gonna calculate first is that that the equivalence of the NaOH, or rather to get to the equivalent point, you use a certain volume of the HCl, and that is equivalent to the end point of the sodium hydroxide. So you really have to do about 2 relationships. First of all, of course you already did it. You already did it by finding the volume by reading it.
Mm-hmm.
And then you use that volume,
yeah,
and the molarity of the HCl.
Right.
Okay.
And that's by dividing the 2 numbers together, what they gave in the problem, right?
Yeah.
Yeah. So I took what they gave in the problem, and then I divided it by my 16.81, and then I got my answer.
Yeah. Because it took the volume of HCl you have to titrate 25 mils of the volume of sodium hydroxide you have to neutralize 25 mils of HCl.
And that would be in liters, correct?
Yeah. All calculations.
Do you want us to round it, like for the 4th? Maybe 1, 2, 3.
It says, like, you gave us everything there in 4 significant figures.
Okay. But to reach the number 5, to reach the equivalent point, if we use the volume that they gave, and to use the equivalent point of that, yeah, I think I'm still confused.
I don't get it.
Me either. Sorry, Professor.
Well, if you can, you get what you did yesterday and go like he did, I think he says 4, 5, 6, 7,
Right.
step by step. That is basically what is done today is to tell you, oh, well, you've done this work step by step. Now, using that information you got, do this.
Well, yesterday in number 4, they gave, we had to figure out the mass, the volume, and the molarity.
Yeah, because it's not given to you. Today, the molarity of the sodium hydroxide is given to you.
So we just have to find the volume and the volume and the mass.
Yeah, and then you correlate it to the 25 mils of HCl that was titrated. Yeah, I know.
Oh my God.
So the molarity is 0.2564, correct? Then the volume will be of what we have on our pH, which mine would be 1681.
Yeah, which would be 0.0601681 liters.
Then I will divide that by the molarity, correct?
Yeah. So right now you have the equivalent. You have X equals to B. You know B. What is X?
Wait, say that one more time. I'm sorry.
Did you do algebra?
Yeah.
If there is something they say in algebra that things which are equal to the same thing are equal to one another. So if A plus B equals C, and you know A or C, you can find B from, you can find the known by substituting the known values. I think I'm making it more complicated.
Yeah.
Yeah. So do what the book says for you to do.
Okay.
So wait, Professor. So for number 5, we convert our volume to liters, and then with that number we divide it by the moles, and that will give us the volume for number 5, correct?
Yeah.
Okay, and with that answer, since does that make it liters, and then do we convert it back to milliliters, or do we just keep it?
You don't need to convert it to milliliters. You need to convert milliliters to liters, but you don't have to convert liters to milliliters to give your answer.
Okay, so with my answer, do I use the unit liters then?
Yes.
Okay.
The author assumes that from what you did yesterday, you know that you're gonna do a balanced equation of the reaction to find out
determining the concentration
exactly
of the solution.
how many
And so let's say
moles
we're starting with an acidic solution. So in here, let's say we have some
sodium
hydrochloric
hydroxide
acid.
is
So we have some
neutralizing
HCl, and we know the volume of HCl. Let's say we're
HCl.
starting with 20.0 milliliters of HCl.
So that
But we don't know
particular
the concentration, right? So question mark here for the
sentence in
concentration of
number
HCl. We can find out that
6
concentration by doing a titration. Next,
assumes
we need to add a
that
few
you
drops
have,
of an acid-base
you
indicator. So
remember
to this flask, we're
the
also going to
steps
add a
you
few drops of
calculated
acid-base indicator. We're going to use
yesterday. And
phenolphthalein.
in fact,
And
that is
phenolphthalein
why I
is
gave you 2
colorless in
lines for
acid, but
number
turns
5.
pink in the presence of base. And since we have our phenolphthalein in acid, right now we have a clear solution. There's no color to it. Up here, we're going to have our standard solution, right? We're going to have a known concentration of sodium hydroxide. So let's say we have a solution of sodium hydroxide, and the concentration is 0.100 molar. And we're ready to start our titration. So we allow the sodium hydroxide to drip into our flask containing our HCl and our indicator. And the acid and the base will react, right? So we get an acid-base neutralization reaction. HCl plus NaOH, right? If we think about the products, this would be OH minus, this would be H plus. H plus and OH minus give us H2O. And our other products, we would have Na plus and Cl minus, which give us NaCl or sodium chloride. So let's say we add a certain volume of base, right? So now this would be higher. And we see our solution turn light pink, right? So let's say we see our solution turn light pink and it stays light pink. That means that all of the acid has been neutralized by the base. And we have a tiny amount of excess base present, and that's causing the acid-base indicator to remain pink. So a tiny excess of base means we've neutralized all of the acid present. And where the indicator changes color, this is called the end point of a titration, right? So when our solution changes color, that's the end point of our titration. And here we stop and we check and see the volume of base that we used in our titration. So if we started right here, right, we started with that much base, let's say we ended down here, right? So we still have a little bit of base left, and this would be the volume of base that we used in the titration, right? So we have a change in volume here, and let's say that it's 48.6 milliliters. So it took 48.6 milliliters of our base to completely neutralize the acid that we had present. And so we can now calculate the concentration of the HCl. All right, so let's go ahead and do that. And let's start with the concentration of sodium hydroxide. Right, we know that we started with 0.100 molar solution of sodium hydroxide. So 0.100 molar. And molarity is equal to moles over over liters, right? So this is equal to moles over liters. And our goal is to figure out how many moles of base that we used to neutralize the acid that was present, right? So we can take our volume here, 48.6 milliliters, and we can convert that into liters, right? So just move your decimal place 3 places to the left. So 1, 2, 3. So that's 0.0486 liters. So this is equal to moles over 0.0486 liters. And so let's get some more space, all right? Let me just rewrite this really quickly. 0.100 is equal to x over 0.0486. So we're just solving for x, and x represents the moles of sodium hydroxide that were necessary to neutralize the acid that we had present. All right, so when you solve
Professor,
for x, you get
for number
0.00486
to
moles
calculate a
of
user
sodium
from your
hydroxide used in our
titration.
titration. Next, you look at the
Is that
balanced
the
equation for
number
what
we got
happens,
for
right? So if I
number
look at my balanced
5,
equation, right, there's a
or
1 here, right, and there's a 1 here. So we have a 1-to-1
Or do we
mole
just-
ratio.
Yeah,
And the
the
equivalence
volume-
point is
from
where
the
just enough
volume
of your standard
of,
solution has been
the,
added to completely react with the solution that's being
sodium
titrated.
hydroxide
And at the equivalence point,
used
all of the acid
to
has been neutralized, right? So it's completely
find
reacted. And since we have a 1-to-1
the
mole ratio,
molarity
right, if I use this many moles of
the
sodium hydroxide, that must be how many moles of
equivalent
HCl that we had
molarity
present in
of
our
the
original solution.
HCl,
So therefore, I can go ahead and write
then
that I
you
must
use
have had
that 25 mils to find the molarity. Like I said, it's assuming that you remember that yesterday you made a balanced equation of the reaction, and you're gonna do the same thing today. How much sodium hydroxide reacting with HCl gives you sodium chloride plus water. And then you do that relationship of 1 mole of this reacts with 1 mole of that to give you the X moles of the other. And when you get that unknown moles of HCl, then you use the 25 mils of HCl to calculate the molarity. So it gave you 2 lines on number 5 because you're gonna do basically 2 calculations when you balance the equation. Then you use it to find the moles of HCl that reacted. From that mole of HCl that reacted, you use it to do the 25 mils of, use the 25 mils of HCl to find the molarity.
0.00486 moles of HCl present in the flask before we started our titration. Right? I knew that because of the 1-to-1 mole ratio. All right, remember, our goal was to find the concentration of HCl, right? The original concentration. And concentration, molarity, is equal to moles over liters. So now I know how many moles of HCl I had, and my original volume of HCl was 20 milliliters, right? So right up here, we had 20 milliliters. So I need to convert that into liters. So I move my decimal place 1, 2, 3. So I get 0.02 liters. So now our final step here to calculate the concentration of HCl, right? So the concentration of HCl is equal to how many moles of HCl we have, which is 0.00486 moles over liters of solution. And we had 20 milliliters, which is equal to 0.0200 liters. All right, so now we can take out our calculator and do this calculation to find the concentration of HCl that we started with, 0.00486, right? And we're going to divide that by 0.0200. And we get 0.243 for our answer. So the concentration of HCl, right, is equal to 0.243 molar. So we've
All right, see you, Jessica. See you. Hope to see you sometime.